Let us learn the concept of arithmetic progression. Arithmetic progression. To understand the concept of arithmetic progression, let us consider 2, 4, 6, 8, 10 list of even numbers. Here a is equal to 2, that is the first term, and a5 is equal to 10, that is the last term. The difference between these two numbers, or the difference between first and second term, in other words, second term minus first term is equal to plus 2. 2 plus 2 is equal to 4. The difference between second and third terms, that is 6 minus 4 is plus 2. 4 plus 2 is equal to 6. The difference between these two numbers, plus 2, that is 6 plus 2 is equal to 8. The difference between these two numbers, 10 minus 8 is plus 2. 8 plus 2 is 10. Here, you see, this is common in all the cases. Okay, the difference is common, and this is fixed. Okay, this is fixed number here. Okay, 2 plus 2 4, 4 plus 2 6, 6 plus 2 8, 8 plus 2 10. Therefore, this is fixed number. So we can denote that number as D, that is fixed number. Fixed number. In other words, this is called as common difference. Common difference. In this case, the common difference is plus 2, that is positive number. Here you see, in this example or in this list of numbers, a is the first term, plus 2 is the fixed number, that is the common difference, and a5 is equal to 10 is the fifth term or the last term. Let us take another example. 25, 20, 15, 10, 5. The difference between these two numbers, 20 minus 25 is minus 5. 20 plus or minus 5 is 20. The difference between these two numbers, 15 minus 20 is minus 5. 20 plus or minus 5 is 15. The difference between these two numbers, 10 minus 15 is minus 5. 15 plus or minus 5 is 10. The difference between these two numbers, 5 minus 10 is minus 5. 10 plus or minus 5 is 5. Here the first term a is equal to 25. Here the fixed number, in other words, the common difference is minus 5. And the last term or the fifth term, a5 is equal to 5. And you just see here the common difference is negative number. Here the common difference is positive number. Let us take one more example. 7, 7, 7, 7, 7. The difference between these two numbers, plus 0 or 0. 7 plus 0 is 7. The difference between these two numbers, 0. 7 plus 0 is 7. The difference between these two numbers, that is 7 minus 7 is 0. 7 plus 0 is 7. The difference between these two numbers, 7 minus 7 is 0. 7 plus 0 is equal to 7. Here the first term a is equal to 7. The fixed number, that is the common difference, is 0. And the fifth term a5 is equal to 7. By using all these three examples, we can define arithmetic progression. Arithmetic progression can be defined as, it is a list of numbers. list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This is the definition for arithmetic progression. An arithmetic progression can be defined as it is the list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Let us take some more examples. So I will take this 1, 3, 5, 7, dash, etc. Here the difference between these two numbers is what? Plus 2. The difference between these two numbers plus 2. The difference between these two numbers plus 2. Okay. First term is a is equal to 1, d is equal to plus 2. We don't have the last term. That is the last term we don't know here actually. Okay. So the last term an is equal to question mark. Let us take one more example. 3, 6, 9, 12, etc. Here the first term is equal to 3. The difference between these two numbers is plus 3, plus 3, plus 3, dash. So common difference d is equal to plus 3. Here also the final term is absent. By using these two examples, we can define the arithmetic progression. Okay, like this. An arithmetic progression can be defined as it is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay, so once again I will repeat the definition. An arithmetic progression can be defined as it is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Here observe, in these three cases the last terms are there. So they have last term, but here they do not have last term. Okay, therefore these arithmetic progressions can be called as finite arithmetic progressions, finite, and these arithmetic progression can be called as infinite arithmetic progressions. So therefore there are two types of arithmetic progressions: finite arithmetic progressions, infinite arithmetic progression. Those arithmetic progressions having finite number of terms are called as finite arithmetic progressions. These are the examples for finite arithmetic progressions. Those arithmetic progressions having infinite number of terms, here you see this contains infinite number of terms, this also. Therefore those arithmetic progressions having infinite number of terms are called as infinite arithmetic progressions. In the examination, so they can ask one simple question: differentiate finite and infinite arithmetic progressions. Finite arithmetic progressions have last term, whereas infinite arithmetic progressions do not have last terms. So that is the difference between finite and infinite arithmetic progressions. Here you just observe here, in all these arithmetic progressions, the fixed number or common difference is here plus 2, that is positive number, here negative number, here 0. Therefore we can say in arithmetic progression the common difference can be positive, negative or 0. So in the examination